So far, when we've talked about light, we've been talking about waves. This wave has a long wavelength, so it has a low frequency and low energy. This wave has a short wavelength, meaning it has a high frequency and a high energy. But it turns out that talking about light and radiation, electromagnetic radiation, as waves is not enough to explain many things. For example, how do fluorescent lights work? Or, how do you make fireworks have different colors? And the answer to these questions involves looking at light in a very different way. Instead of looking at light as a wave, we actually have to look at light as a particle. So instead of, if you imagine light coming at you into your eyes that you can see, instead of this light coming out of your firework, let's say this red firework has a red wave coming out of it, actually what it's sending at you are particles of light, little pieces of light. This was discovered by Albert Einstein in his photoelectric effect experiment, and it was one of the experiments in which he won his Nobel Prize. But what exactly is a photon? Well, a photon, as was just stated, is a particle of light. The higher the amplitude of the light, or the brightness, the more photons there are. And this is really important. The brightness of the light is not due to the energy of the photon, but just to how many photons are present. The energy of each photon of the same color is the same. And remember, color only really refers to visible light, but we can also talk about the types of light. So if I have one type of light, one wavelength of light, the energy of each of those photons is the same. And still, the higher the frequency, the higher the energy. So how does this apply to chemistry? You're taking a chemistry class, right? Why are we talking about energy and light? Well, it's all going to come together in the Bohr model.